Here we are, Math 1, Practice 2.5.1, Graphing Linear Functions. Okay, so we're going to deal with those linear functions, a few of their features of functions. I may talk about more, but we'll deal with it that way. Alright, 1 and 2, it says given the function, then it gives us our function. We should be able to tell it's linear because it's multiplying by x, and we've got the plus 4 here. Use the slope and y-intercept to graph the function. Identify the x and y-intercepts. So, normally we'd have our graph. Okay. Remember, this way we write it is y equals bx plus a, or a plus bx. Okay. Where the one without the x, that's our y-intercept. So our y-intercept would be 4. So we draw our point. Then our slope, our rate of change, would be the one with the x, the b. So negative 4 over 3. Remember, it's always y over x. So we'd go down 4, because it's negative 1, 2, 3, 4, and then to the right 3. 1, 2, 3. Okay, and we'd follow that pattern. And then you draw your line. Okay. Now the x and the y-intercept should be pretty easy to see. Sorry about that, Bell. Anyway, our y-intercept is where it crosses the y-axis, right? The point would be 0, 4. And our x-axis is where it crosses the x-axis. So our point would be 3, 0. Okay. Very important that you notice that for all y-intercepts, the x value is 0. For all x-intercepts, the x value is 0. Now, you could graph those by hand, or you could also use some graphing tools. We have our graphing calculators that we can use. We also have the website or app that you can download to your phone, which is desmos.com. Website, or just Desmos if you download the app. That's a really great graphing tool. I would suggest downloading it on your device to use. I may start allowing you to use it in class, because from what I understand, at our end of year test we'll also be able to use it. So let's take a look at what that graph would look like. Alright, so we're dealing with this graph right here. As we can see, y-intercept started out at 0, 4, crosses the y-axis. We go down 1, 2, 3, 4 to the right, 1, 2, 3, and there's our x-intercept because it crosses the x-axis at 3, 0. Okay. Now, a few of those other features we talk about, positive and negative aspects. Well, the graph is negative from here down, and we know it keeps going. So if we were to talk about that negative aspect, it would be from 3, the x value of 3, and then it keeps going to the right to the x value of infinity. For negative. For positive, going up, at 3 it stops being positive, so that would be the end, and then it's positive as we go to the left, which we call negative infinity. So that's how you'd write for the positive negative of this graph. Okay. Domain and range. Domain is going to keep going to the left and to the right, so the domain would be from negative infinity to positive infinity. The range, remember how far down and how far up it goes. Well, it keeps going down to negative infinity and up, so it'd be negative infinity to positive infinity. Okay. It's always decreasing as we look left to right. It's always going down, so it would never be increasing. Decreasing would be, once again, negative infinity to positive infinity. Okay. And then there's no max or minimum because it keeps going down and it keeps going up. Okay. So just a few of those other features. It is a function. Of course, we have it in function notation, so that helps us see that. Okay. So in Desmos, it's great. You just type in your problem exactly how you see it. It shows you the graph and helps you find those easy points. Okay. All right. So number 2. Same idea, right? So that would be our y-intercept. So we'd go up to 2. Okay, we draw our y-intercept. Then our graph goes up 2 to the right 7. So up 2 more to the right 7. So it would be right there. So our graph would go this way. So our y-intercept, pretty easy to see, that's going to be 0, 2. But what about our x-intercept? Well, let's keep going the opposite way. So if our slope was 2 over 7, y over x, and we went up and to the right, we could also go down and to the left. So I could go down 2 to the left 7. So down 2 to the left, right about there. So that would actually be on the x-axis, so our x-intercept would be -7, 0. And if you weren't sure about that, again, we could have just graphed this one, couldn't we? And you can see from here, okay, you can see where we're down 2 to the left 7, okay, and we've got our x-intercepts. Now this one would always be increasing because it keeps going to the right and to the left. We know the domain keeps going down, keeps going up. The range, the increasing wouldn't ever be decreasing, no max or no mins, would be from -infinity to +infinity. Okay, x-intercept, y-intercept, positive and negative. Right here is where it switches from being negative. Negative would be from -infinity to -7. Positive would be as it keeps going to the right, so it would start at -7 and keep going to +infinity. So they'll never come back down. These functions, these linear functions. All right. Okay. All right. Now let's look at 3 and 4. So 3 and 4 give us a table and want us to find them. So remember, for x-intercepts, they're always going to be a number, comma 0. For y-intercepts, always 0, comma a number. So look at your graph. And remember, f of x is the same as the y value. Okay. So we have a 0 for x and a 5 for f of x. 0 for input, 5 for output. So our y-intercept is going to be 0, 5. Okay. And our x-intercept is going to be 3, 0, right? Because we find 0 here and we get the 3. Now, could we graph those? Yeah. So if you were to graph those, you'd go 0, 5, draw a point, 3, 0, okay? And that kind of gives you your slope, doesn't it? You'd have to go down 5, to the right 3. So we could graph that just by doing that. You could even write the equation, because it gives us our y-intercept, and it'd be f of x equals -5/3x plus 5. Okay? And so you could graph that one as well. Desmos doesn't allow you to just, you could graph the points and figure that out, but not as helpful. But you could still use it to give you a general idea. So 4, same idea. So we've got -7, 0, and we've got 0, 2. That's a -7. Now, which one's x, which one's y? This x value is 0, which makes it the y-intercept. The y value is 0, making it an x-intercept. Okay, if we were to graph that, we've got -7, 0, 0, 2. Should look pretty familiar, this one. Okay, we see it right there, don't we? Yeah. Okay, because that slope up 2 to the right 7, so f of x equals 2/7x plus 2. Okay, that function is that table right there. Alright, now 5 and 6 say, given the function, solve for the x and y intercepts, use the intercepts to graph. Now, understanding that if we make a table, to get the x-intercept, the y would be 0. To get the y-intercept, the x would be 0. So, you could take this f of x and make it 0 and solve for x. So we'd subtract 2, get -2 equals -2/3 x times by 3. That would get rid of our fraction. So we'd have -6 equals -2x, right? 3 times -2, divide by -2, and that would give us a +3 for x. Okay, that gives us one of them. That gives us our x-intercept. Now to find our y-intercept, we make the x 0. So I'd go f of 0 equals -2/3 times 0 plus 2. That becomes 0, plus 2 becomes 2, so f of 0 equals 2. So that equals 2. Then I could use that to graph, and draw my graph that way. Or I could use the equation to graph like we did in 1 and 2. Or, as usual, we could just use our technology to do it. And we can see those X or Y intercept and X intercept and all that stuff. Okay? And once again, our domain and our range and our decreasing would all be the same, right? Because this keeps going to the right and to the left. Also keeps going up and down. And it's always decreasing, so that would be negative infinity to positive infinity. Okay, no maximum, no minimum. Y intercept, X intercept, positive and negative. Well, that X intercept is going to stop them, right? So it starts positive, clear out here to negative infinity, and then it goes till it gets to positive 3. So it look like that for negative. It starts at this positive 3 and then keeps going to the right negative, so it'd be to not negative infinity, positive infinity. Okay. Alright. So, let's look at number 6 now. Number 6 wants us to do the same thing. So once again, you could start off and just go, well, y-intercept at negative 5, slope of 5 over 4. Okay, and we can see the x and the y-intercept. The y-intercept is 0, negative 5. X-intercept ends up being 4, 0. But they don't always work that way, so that's why we can't always just start graphing it that way. Okay, so if you need to find them, you can also do it like we said. So to find the x-intercept, you make the y 0, or the f of x 0, and solve for x. To get the y-intercept, you make the x 0, right, as if we were making that table. And then we solve for x, or we just simplify. So that becomes 0 minus 5, negative 5. That one's easy to do, right? And that's where we got that. Then you could, for this one, add 5. So 5 equals 5 over 4x times by 4 over 5. Okay, those would cancel, times by 4 over 5. Those would cancel. You get 4 equals x, which is what we got. Okay. And then we could graph those 2 points and then draw our line, like that. Or we can use technology to graph it to find the same stuff. Once again, this keeps going to the right and up, so the domain, and to the left and down. So we always have x values, so all the x values work. The range, all the y values work. It's increasing as we look left to right, so all of those go from negative infinity to positive infinity. It's never decreasing. There's no max, no min, right? Doesn't have those because it keeps going up. And y-intercept, x-intercept, and then the positive and negative. 4 is kind of where it stops. Negative, we start out at negative infinity, and we're negative until we hit 4. So we go negative infinity to 4. For positive, it starts at 4, and then as we go to the right to positive infinity, it's up above. So 4 to positive infinity. Alrighty, there we go with those ones. Okay. Now let's take a look at number 7. 7, 8, and 9, now we've got story problems. Okay. So, Kaylee is selling candles to raise money for her lacrosse team. The large candles sell for 25 and the small for 10. She needs to raise 600. Write a function to represent how many types of each candle she needs to sell. Okay. So, we have large, we'll say L for large candle. And we have S for small. Okay. Now, how much does the large cost? 25 each, right? So if I take 25 and multiply it by how many I sell, that'll give me that cost, right? Then, if I take 10 and times that by how many small ones I sell, that'll give me the cost. I add those together, add those together, that gives me that cost, or the whole amount I'd get, which I want it to be equal to 600. Okay? So now this one's a little different than over here, but the same idea works. Okay, it says draw the graph of the function. Okay, well, what I can do is change that L to X, change that S to Y, and then I could use technology and graph it that way. So if I use Desmos or another graphing, I can type it in just like that, and notice that we end up with our graph. Now notice I'm counting by 20s here. So 5, 10, 15, 20. Okay. Then I can see my y-intercept. I can also see my x-intercept. Now what do these mean? Okay. Well, remember the x stood for the large candles, the y for the small. So this line is all these points here, all the different possibilities to equal $600 of how many I need to sell. So if I only sell 24 of the large, that would give me $600. If I sold 60 of the small, that would give me $600. Okay? So that x and y intercept, that's what they mean. Okay? So we could draw it that way, or we could do it like this. Here's the other way we could draw it. Okay? So it goes with this idea. If she sells only large, how many would she need to sell? So if she's only sold large, 25 times L, we wouldn't sell any small, right? They would be 0. And you could solve it that way. Kind of like how we did over here. We made the y value 0 and we made the x value 0. That's another way you can do it. Okay, 10 times 0 is 0. 0 plus that is 0. Divide by 25, and we would have ended up with 24. Okay, so we'd go out here to 24, wherever that is, and draw our point. Then we do it for if we only sold small. So it would be 25 times 0 plus 10s equals 600. That would be 0, so we'd get 10s equals 600. Divide by 10, and we'd get s equals 60. So going up here, we'd go clear up to 60, and then we could use that to draw our line. And then every single point here is a possibility of how many we could sell to get 600. Okay, so that's kind of how you can do those ones. So let's try another. Jerome knits scarves and hats for charity. Scarves require 4 skeins of yarn, and hats require 2 skeins. A skein is like when you go to this fabric store and you have the fabric, and it's got the little thing here, and there's all your fabric. That's a skein. Jerome has 24 skeins of yarn. Write a function to represent the combination of scarves and hats he can knit. Draw the graph of the function. So same idea. So we treat it the same. So we have scarves require 4. So let's say X is for scarves. How many? So Y would be hats. So to make a scarf, I need 4. So I'd go 4 times X. To get a hat, I need 2. So it'd be 2 times Y. Add those together, that would equal 24 skeins of yarn. So we want to see how many of each we can make. So, probably an easy way without technology to do this would be to do that idea, well, what if I only make scarves? So 4x would equal 24, right? Because we technically would go 4x plus 2 times 0 equals 24. And then that would be 0, so you divide by 4, and you get x equals 6. Okay? So I go out there and graph at 6. That's my x-intercept. Because x equals 6 when y equals 0. That's the point. Then I do it for our hats. So I'd go 4 times 0, which would be 0, so I end up with just 2y equals 24. Divide by 2, and we get y equals 12. So that y-intercept would be 0. 0 for x, 12 for y. So draw that point up there. And then there's my graph. Okay, and once again, all these points here represent how many scarves or hats or whatnot to make. But we can also graph it just like we did here, can't we? And we can see the same thing. I type in my equation. There's my y-intercept, there's my x-intercept, and what does it mean? If I wanted to use just the 24 skeins of yarn to make scarves, I could make 6. To make hats, I could make 12. Alright, number 9, same idea. So a farmer raises goats and cows. Each goat requires 400 square feet of grazing area, and each cow requires 1,200. The farmer has 36,000 square feet. Okay, so write a function. So we've got, let's call X for goats, Y for cows. So the number of goats he has times how much space they need plus the number of cows he has times the space they need cannot be greater than, so it has to equal. We want it to equal because we want the most possible, 36,000. So to start off, to find the X-intercept, you could make the Y 0, so 400x plus 1200 times 0 equals 36,000. So that becomes 0. We have 400x equals 36,000 divided by 400. 0 cancels, 0 cancels. 360 divided by 0, that should be what? 90? So x equals 90 divided by 4, I meant. So we can have 90 goats. Okay, if we have no cows, you could have 90 goats. Okay, so that's what that would be, 90. Okay, how about only cows? So for only cows, that's like the Y-intercept. So I'd go x this time is 0, right? Because the point would be 90, 0 for goats, plus 1200 y equals 36,000. That's 0, so we basically just divide by the cow's space. 2 zeros cancel. 360 divided by 12 should be 30. So we can have 30 cows if we have no goats. So cows, we could have 30, but it's the y, so it would be 0, 30. Okay. Now to graph it, you can just do that and go clear out to 90, up to 30, and draw, or using technology, we can do that too. And once again, we can see we had to zoom out, but we can see the same information. Okay? So that technology can be very helpful, but you got to understand what the pieces mean. Alright, so last one, number 10. The graph of the function is shown below. Write a scenario that could be represented by the graph. So let's find our X-intercept. So 3, 0. By the way, we've been using on these ones the standard equation, ax plus by equals c. Okay? If you ever have situations like this where you have two different things, those are great ones to use. They also are helpful for the X and Y intercept. Y intercept is 0, 15. Alright? So, you could say, any sort of scenario where one you would need 15 of, if that's all you had, and the other one you would need 3 of, could work. So kind of model after these, and they would have to equal something, so you need to figure out what they're equaling. To do that, you need to figure out what number would work both for 15 and 3. Okay? So the best way to do that is to come up with that equation. So I would probably go 15 times 3, which would give us 45. Okay, would equal 15x, because 45 divided by 15 would be 3 plus 3y. You could do it that way, or you could just kind of like multiply up. So if I doubled it, I could have 30x plus 6y equals 90, or keep going to go 45x plus 9y would equal 135, or something so that when you divided you would get the right number. Okay? Or you could even go, I think 5x plus y, 1y, would equal 15. Okay, those are all sorts of possibilities that you could do. And then just come up with something where You know, maybe like it's $1 to buy a popsicle, $5 to buy an ice cream. If I only have 15 customers, how many have I sold of each one, kind of thing, or something like that. I'll let you guys use your own imaginations on that one. So there we go.